Hi dear students. So today we will discuss the device which is working on the principle of the electromagnetic induction. So we have seen if you change the magnetic field related to one coil, there will be the generation of current in the coil. That is known as the electric or inductive current. That current it is known as the inductive current. And the current forms due to the variation in the potential at the ends of that conductor. So that EMF generated or the potential variation generated is known as the induced potential or induced EMF. It is known as induced EMF. So the electric generator is the device which is working on the principle of this electromagnetic induction. Okay. So electric generator is actually it is converting the mechanical energy into the electrical energy. Okay, but as we have studied in the case of the electric motor, it is converting the electrical energy into the mechanical energy. Now you can see the various parts of electric generator in the picture. Similar as there in the case of the electric motor, a permanent magnet is there, a coil, and here this generator is actually AC generator. So instead of the split ring commutator, we are using the slip ring commutators. So that means here the ring R1, if you are considering the ring R1, that is the first ring, this one. The ring R1 will be always in contact with the end A. Okay. The loop end A will be always in contact with the R1. And hence the brush B1. Okay. And the ring R2 will be always in contact with the end D, end of the coil D, and as well the brush B2. Okay. So now let us come to the theory portion. So here electric generator, it is actually changing the mechanical energy into the electrical energy. Okay, with the principle on the working principle of electromagnetic induction. And then you have to specify what is the electromagnetic induction. That is, whenever the magnetic field related to one particular coil varies continuously, then there will be a generation of a potential difference in the ends of the conducting coil, or we can say a generation of a electric current in the coil, and that is known as the induced current. So by applying this mechanical energy, we are rotating this coil. As the coil rotates, the magnetic field related to that coil will change continuously. As a result, there will be the generation of the electric current in the coil, and we will use that current for our applications or for our uses, various uses. Okay. So that is actually what's happening in the electric generator. And now in detail, in which direction the current flows, whether it will change the direction. Okay, is there any changes in the direction happens, or will it be in the same direction, or direct current, whether this generator is producing a direct current or a alternating current, all those things that we have to see. Okay, so first of all, the working principle. So the working principle already I have told you that working principle of the electric generator is the electromagnetic induction. And the next one, the mechanical energy is converted to the electrical energy. So an electric generator consists of a rotating rectangular coil ABCD. Okay. So here the coil you can see A, B, C, D. Okay. A, B, C, D. Okay. Now so this ABCD, it is placed in between two poles of a permanent magnet. So two ends of the coils are connected to two rings R1 and R2. But always R1 means end A will be always in contact with R1, as well end D, and the loop end D will be always in contact with R2. And as well the R1 and R2 are connected to the brushes B1 and B2 respectively. So all those things are you have already seen. Then the R1 means R1 R2 B1 B2, and but in the case of the motor we were using the split ring. Okay, here we are using the slip rings, so we can obtain the AC current. Okay, and the motor that we have studied, the DC motor we have studied. Okay, we have discussed the DC motor. So where we have used a split ring, but here you are using slip ring. Various two rings we are using, and the ring will be always in contact with one of its end. Okay. The means R1 will be in contact with A and R2 will be in contact with the D always. Okay, that will not change. And as well, if you are increasing the number of turns in the coil, then you can increase the current generated, or induced current you can increase by increasing the number of turns in the coil. Now this R1 and R2 are internally connected with the axle, and inside inner portion of this rings R1 and R2 should be insulated. That means a direct contact should not be there with this R1 R2 along with that axle. Okay, to avoid the short circuit, we have to insulate the inner portion of R1 and R2, and we have to connect that one with the means we have to place that one on the upon the axle. Okay. So as we are rotating the axle mechanically, so along with the axle, what will happen? The coil also will start rotating. The coil and along with the rings that will rotate, the brushes will be stay on its position. That means the brushes will be stable in such a way to keep the connection constantly. Otherwise, if the brushes are also rotating, then what will happen? The connections will break. Okay, that we have discussed in the motor section, the function of these brushes. What is the function of the brushes? Brushes will be always in a actually the brushes will be pressed towards R1 and R2 respectively. B1 and B2, the brushes will be pressed towards the R1 and R2. It is not in connect. We cannot say that it is connected. A fixed connection is not there, but it is in contact. Okay. So in such a way to continue the connection, or keeping the constant connection. Okay. So here you can see the connection, it is towards a galvanometer. It is connected towards a galvanometer. So as the current is generated, a galvanometer needle will deflect. There will be, we can see, we can observe the deflection in the galvanometer needle. Okay. Now, so here consider we are rotating the axle in such a way this the AB moves upward. As the AB moves upward, CD will move down. Okay. So if you are observing from the side of this axle, that means the rotation will be a clockwise. in a clockwise direction. AB moves upward, CD moves down. You are observing this rotation from the side of this axle. So you can see that it is a clockwise rotation. AB is moving upward and okay. So you are observing from here. Consider that is AB is moving upward and the CD is moving downwards. Okay. So it will be, we can say it is the coil it is rotating in a clockwise direction, and thereafter now we have to use the Fleming's right hand rule. So Fleming's left hand rule we have used to find out the direction of the force, and the Fleming's right hand rule we will use, or we are using the Fleming's right hand rule for finding out the direction of the induced current. So here you have to use the Fleming's right hand rule. Okay. So as you are using the Fleming's right hand rule, so here the movement of AB is upward. Okay, movement of AB is upward, and the direction of current, the direction of the magnetic field is from north to south. That is left to right. Okay, so your thumb will be representing the direction of the force or the direction of the motion. Here the direction of the motion is upward, and your index finger is representing the direction of the magnetic field. So just keep your finger in such a way, your right hand in such a way that first of all you have to stretch the fingers. That means the first thumb, index finger and the middle finger should be perpendicular to each other. Such a way you have to stretch, and your thumb will be pointing upward and your index finger will be pointing from the north to south. Okay, then you can see that your middle finger will be pointing towards your screen. Okay, that is from A to B. So the current is passing from A to B in the coil AB. Okay, in the arm AB, in the portion of that coil AB, the current is moving inward. Okay, into your screen. Now, if you are considering the arm CD, the direction of the current, the movement is actually upward. So your thumb should be pointing downwards, and index finger should be pointing from north to south. North to south direction you have to keep the index finger. So your middle finger will be pointing outwards from your screen. It is moving out from the away from the screen, or towards the outside the the middle finger it is pointing. So that means in the arm CD, the direction of the current it is C to D. Okay. So direction of current it is continuous. So in AB it is A to B, and in CD it is C to D. That means in the entire coil the direction of the current is A, B, C, D. And A it is connected with the B1, and D it is connected with B2. So as the current comes from A, B, C, D, then again it is moving towards B2. From B2 it is moving like this, and it is coming B1 and reaching B1 and again A. So inside the coil or inside the generator, in the coil, the current is passing from ABCD, and outside the coil the current is passing from B2 to B1. Okay, B2 to B1. Now consider half of the rotation it is finished. That means AB will reach here and CD will reach here. Okay. So the next naming will be like this. So this is D, this is C, this is A, sorry, this is B, and this is A. And as well, AB should be always in contact with B1, isn't it? So we will rewrite this one as B1. So because AB should be always in contact with B1, so this is B1 and this is B2. As well, R1 and R2 also changing. Now I am not writing B1 and B2, I am writing only. Okay. Otherwise, this one will be R2 and this one will be R1. Okay. Now, again, here the CD is moving upward and AB will be moving downwards. The rotation, it is in the same direction only. That means the CD moves upward. After one rotation it will become like this, and CD moves upward and AB moves downward. Again, here in the case of the CD, the current will be from D to C. Earlier the current was from, if you are drawing that diagram, this was A, this was B, this C, and this CD. In the earlier case, initial when the rotation initiate, the coil was like this, and the current was A to B and C to D. Here, if you are using the Fleming's right hand rule now, in C to D and D and C, if you are considering, the current will be from D to C. That means the current is reversed its direction. Okay, and as well from B to AB, the arm AB, if you are considering, the current will be from B to A. Okay, B to A. So the current directions reversed, that is B to A and D to C. So here it is B2 and here it is B1. Hence the direction of the current will change from B1 to B2 outside the coil. Earlier it was from B2 to B1. Now it is B1 to B2. That means the polarity is changed. So earlier we can consider maybe the B2 is in positive and B1 is in the negative. That means from B2 to B1 the current passes. Now B1 become positive and B2 become negative. That means the current passes from B1 to B2. Okay. So the current direction is changed after one rotation, or after the half rotation, the direction of the current reversed, or the polarity, it is reversed or changed. Okay. Now I think this much is clear for you. Now let us come to the theory portion. So initially the ABCD is in the clockwise direction. So beginning of the initial, or at the beginning of the rotation, the current was from A to B and then C to D. So in the outer circuit, the flow of current was from B to B1. And after the half rotation, the current direction will change. That is due to the reason we have already drawn, and I have explained to you, that is CD will move upward, AB will move downwards. So the current direction will be from DCBA. It is reversed. As well outside it will be from B1 to B2. That means the polarity of the current, or the polarity changed. So as a result, means if the polarity was constant, if it is not changing, you can obtain a direct current. Okay, so now the polarity is changing. That means consider this is as the origin, this is positive and this is negative portion. So for initially the first rotation, that AB is moving upward. AB is moving upward, it means the current value is increasing and it reaches a maximum, and now it reached, it means one half rotation it is finished. Now the value will become 0. Now the AB is moving downwards. Okay, AB is moving downwards means the polarity is changed. It means now the current direction will be in the negative direction. Okay, so negative direction, it means the magnitude is increasing, but if you are considering all the value, that means it is decreasing, and after a particular point it will start increasing and reaches 0. Again it will increase in the positive direction, again it will decrease in the negative direction, likewise after each half rotation. Okay, so this is known as the AC, or the alternating current. It means in the positive and negative direction it will alternate after each half rotation. Okay, now in here, from one crust to one other one, nearest crust, or one trough to other trough, the distance, it is known as the wavelength. That is the complete wave. Okay. Now you have to you should know two, three terms. That is, what is frequency? Frequency is the number of waves. That means the number of wavelength, number of each wave. That means if you are considering this is as a wave, this type of, how many number of this type of waves or this type of portions are passing through one particular point in 1 second, that you have to measure. That is the frequency. Okay, so number of complete waves passing through one particular point is known as a complete wavelength, a complete full wavelength which is passing through one particular point in 1 second, it is known as the frequency. Okay, now as you are observing the frequency, so here in India the frequency of the current, it is 50 hertz. 50 hertz is the frequency of current in India. Okay, that means one frequency in the sense, one complete wave in the sense, 2 times the polarity it is changing. Okay, 2 times the polarity is changing. That means totally the change in the polarity will be 1 by 100 second. 1 by 100 second will be, or 1 by 100 second is the time required for the changing of the polarities. Okay, from positive polarity to negative polarity. So how many times the polarity it is changing? 100 times it is changing. And 50 hertz means the number of waves which are passing through one point in 1 second. So for the time required, it is 1 second for a total 50 hertz. Okay, so the polarity means one portion of that wave, it is having 1 by 100 second time, and after that it will change again. That require that the duration will be 1 by 100, and this one will be also 1 by 100. It means there are total 100 waves are there, and for that, it means 100 parts are there. Likewise, if you are considering this portion, okay, 100 polarity parts are there, and it requires only 1 second. Okay, simply we can say the AC changes direction after every 1 by 100 seconds. Okay, and its frequency will be 50 hertz. And in our home, in our houses, the house appliances or home appliances, we are using the AC current. And the major reason of using this AC current, it is we can transfer this AC current through a longer distances or far distances we can transfer without much energy loss. Okay, that's why we are preferring, or we are using the AC current. And in the case of this generator, if you are using the slip rings, you can produce the AC current. And if you are using the slit rings or the split rings, okay, if you are using the split rings, then you can produce the DC current. Okay, these are the major things. Once you go through the textbook, read the textbook thoroughly. Okay, and also you just go through the exercise questions and answers also. Okay, so thank you.